Welcome to the pre-calculus video for Unit 2A, Lesson 2, Polynomial Reduction using Synthetic Division. Hopefully you've seen synthetic division before. That will make this go a lot easier. But either way, if we are looking at a division problem like this, we're considering 3x squared minus 13x minus 10 divided by x minus 5. And we've decided that we want to use synthetic division. Instead of setting up polynomial long division like we did in the last lesson, there is a much more compact and some would say direct method that we can use called synthetic division for problems where in our denominator the lead coefficient is 1 and it is a linear binomial. Now, what we're going to talk about first is just the setup. Right here in this nice little box at the top, we are going to write our root. Now, what you should remember is that we can get a root from a factor or a divisor by setting it equal to 0 and solving. So we're dividing by x minus 5. If I take x minus 5 and set it equal to 0, when I solve that, I get x equals positive 5. So I'm going to put positive 5. Along the top, I'm going to put the coefficients of my numerator. So here I have 3x squared. Instead of writing 3x squared, I'm only going to write 3. Next, I have negative 13x. I'm not going to write the x. I'm just going to write negative 13. And my last term, which is a constant, I'm going to write negative 10. Now, along the bottom is going to be my solution, which I'm going to call my quotient. But again, it's only going to be coefficients, so I need to be mindful of what that looks like. This middle line here, this is going to be some products that I'm going to be adding. Now, once we get into the process, some of these will make more sense, but this is where that information goes. At this point, I don't know what that is, so I can't write anything there. So let's actually go through the process of synthetic division. You'll notice on the right-hand side, there are steps and look-fors. So anything that you need to write down here to help you better do these problems is going to be very helpful. Now, I'm going to start how I started the other. I'm going to write my root of 5. I'm going to write my coefficients of 3, negative 13, and negative 10. Now, the way that this process is going to begin, I'm going to bring down my first coefficient, and I'm going to write this 3 underneath the line. Next, I'm going to take this 3 that's underneath the line, and I'm going to multiply it by my root 5. 3 times 5 gives me 15. I write this 15 above the line because that is my product that I will be adding. So I'm going to add this 15 to this negative 13 and say, okay, negative 13 plus 15 gives me positive 2. I write this positive 2 below the line because I am adding down. Just like I did with the 3, I'm going to take this positive 2 and multiply it by 5. Positive 2 times 5 gives me positive 10. And I'm going to add down again. Negative 10 plus positive 10 gives me 0. Now I'm going to mark a line here to take this last term, this 0, and separate it. This is where I will find a remainder if I have one. Now, The last piece that we need to do with this is we need to make sure that we're putting this back in a format that we can use. Now, what we can tell already is if I look up here just at my first term and I see 3x squared and I'm dividing by x, what I should be getting is 3x, because 3x times x gives me 3x squared plus 2. Now, just to be clear, this term, this first term of my quotient, will always have a power 1 less than my numerator. So my numerator, it was 3x squared. The first term of my quotient is going to be 3x because this is always going to be an x here. For any remaining terms like this plus 2, we are going to have descending powers. So this is 3x. We don't write it, but it's 3x to the first. So the next descending power would be no x at all. When we start looking at some problems that have a few more terms, we'll notice that maybe our answer will be squared, and then we'll have an x term, and then we'll have a constant term. So that's something that you really want to look out for. Just like with polynomial long division, using synthetic division, we sometimes get remainders. So I'm going to set up this problem. We'll go through the process and we'll talk about how to deal with any remainder that shows up. Here we have 2x squared minus x minus 15 divided by x plus 3. So the first thing I'm going to do is I'm going to say x plus 3 equals 0, gives me x equals negative 3. That tells me the number that's going to go up here at the top left, my root. Across the top, I'm going to put my coefficients. So 2, negative 1, negative 15. Just like in the last problem, I'm going to bring down my first coefficient of 2, multiply it by negative 3. 2 times negative 3 is negative 6. Then I'm going to add down. Negative 1 plus negative 6 is negative 7. Take this negative 7, multiply it by negative 3, and I get positive 21. When I add down, this leaves me with a remainder of 6. Again, I'm going to look here at my first term. My first term was x squared, which means this will just be 2x to the first. Bring down my minus 7. Now I've got this 6. Just like with polynomial long division, our remainder is written as a fraction, so I want to add 6 divided by my divisor, which is x plus 3. So we're treating this the same way that we treat polynomial long division quotients. We're going to write the terms that we have, and then our remainder will always be divided by our divisor. Looking at our next problem, we ask the question, what about missing terms? We are going to approach missing terms the same way in synthetic division as we do in polynomial long division. So we have 2x cubed. So we have our x cubed term. That's my x cubed. We have minus 3x squared, which is my x squared term. Again, we do not have an x term, so we're going to say plus 0x. That's my x term. Plus 5, and that's my constant. So when I go to put in my coefficients, I need to make sure that I include that 0 because it has a place. It's a placeholder. So I'm going to start the same way I always do. I'm going to say x minus 2 equals 0, which gives me x equals positive 2. That is the number that goes up here, my root. I'm going to write my coefficients, 2, negative 3, 0, 5. Bring down my first coefficient, 2, multiply, 2 times 2 is 4. Add down gives me 1. 1 times 2 is 2. Add down gives me 2. 2 times 2 is 4. Add down, 5 plus 4 is 9. So I had my missing term. I also have a remainder. So looking at my numerator, this time I am starting with x cubed instead of x squared, which means that when I begin to write my answer, I want to go 1 less than x cubed. So I will take this 2 and say that is 2x squared plus 1x. Notice we're using descending powers. This is x to the second, this is x to the first, plus 2, which is my constant term. I do have to deal with this 9 as a remainder, so I want to add 9 divided by x minus 2. Just a few more synthetic division examples, so that way you have some practice. If you wanted to pause the video and try these on your own first, that would be a really good idea. So I'm just going to break in with some setup. I'm going to draw my box. Here is x plus 2 equals 0, gives me negative 2. Write my coefficients, 1, 5, negative 3. Bring down the 1. 1 times negative 2 is negative 2. 5 plus negative 2 is 3. 3 times negative 2 is negative 6. Add down gives me negative 9. So this gives me 1x plus 3 minus 9 over x plus 2. Setting up my second, again, I draw the frame first. I have x minus 3 equals 0, which gives me x equals positive 3 as my root. Write my coefficients, 2. Notice here that I am missing the x squared term, so I need to put a 0 in for x squared. Minus 11 plus 7. Bring down the 2. 2 times 3 is 6. Add down gives me 6. 6 times 3 is 18. Add down gives me 7. 7 times 3 is 21. Add down gives me a remainder of 28. Since this one started with x cubed, I'm going to start my answer with x squared, 2x squared, plus 6x, plus 7, plus 28 divided by x minus 3. So be very careful about how you are multiplying, how you are adding, and identifying those missing terms where you'll need to put a 0. As always, at the bottom of this page is note summary. Jot down any questions or comments that you want to make the next time that you are in my class.